this presentation, we're going to learn how to solve a quadratic inequality. Example number 1 reads, x minus 5 is smaller than 0. Now this is not quadratic, but it is an inequality because of the smaller than sign. So we want to know when will x minus 5 be smaller than 0. And it's easy enough to solve. We can just take 5 over to the other side, and if x is smaller than 5, my answer will be smaller than 0. In example 2, I have x squared minus 25 is smaller than 0. Now this is a quadratic inequality, and what makes it quadratic is the square. Now if we try and use a similar method to example 1, we could take 25 over to the other side. And we know from past experience, if we want to get rid of a square, we can square root both sides. And we end up with x smaller than 5. But now because of that square, in an equation I should usually get two solutions. So what would the other solution be? Well, minus 5 times minus 5 is also 25. So could the other solution possibly be x is smaller than minus 5? But this makes no sense. How can x be smaller than 5 and smaller than minus 5? So we need to look at it from a slightly different perspective. Are we going to look at just x squared minus 25 for the moment? And you should remember that if we have to sketch the graph of x squared minus 25, it is a positive parabola. And if I'm concerned with where that graph is smaller than 0, I'm concerned with the area that is underneath the x-axis. So now we're looking at it from a slightly different perspective. So how can I determine what part of the graph is below the x-axis? Well, I will need these 2 points here. And what are those 2 points? Well, those are the x-intercepts. So if I now think of equations and I want to find the x-intercept, I can make the equation equal to 0 and then factorize it. So we're going to do the same thing now. Just factorize the expression and you end up with x minus 5 and x plus 5 is still smaller than 0. So I know that those x-intercepts on the graph are 5 and minus 5. Now the area that is smaller than 0 is the area highlighted in pink. So it's all real numbers between minus 5 and 5. In other words, a round bracket for minus 5 and it ends at 5 with a round bracket. Pause now to make some notes. Example 3 says x squared minus 4 is greater than or equal to 0. So now we've got greater than or equal to. The only difference the equal to will make is it will change the brackets when we write down the solution. So we'll look at that in a few minutes. But at the moment, we're just going to concentrate on x squared minus 4. And if we have to sketch that, again, it will produce a positive or happy face parabola. And if I'm concerned with the area that is greater than or equal to 0, I want to know what area is above the x-axis. So I want to know what those x-intercepts are. So we're going to start by factorizing the expression. And x squared minus 4 factorizes to x minus 2, x plus 2, which means that those x-intercepts will be 2 and minus 2. In an inequality, we call them critical values, but they're basically just the answer to the equation. Now I want to know which area is greater than or equal to. And if you look carefully at the parabola, there are two sections that are greater than 0. The first one is on the left. Now this will stretch from the left-hand side at minus infinity and end at minus 2. And because of the equal sign in that inequality, I need to change it to a square bracket. Then I've got another portion on the right that is above the x-axis, and it starts at 2 and stretches to infinity. And again, because of the equal sign on the inequality, we need to use a square bracket. We don't use the y-axis at all in solving inequalities, so for now we're just going to ignore it. We will use it again when we start sketching quadratic functions in a few months' time. To summarize quickly, if your answer, or if you're looking for a solution that is greater than 0, you're looking for the area above the x-axis. And if you're looking for a solution smaller than 0, you're looking for the area below the x-axis. So let's look at example 4, which says minus x squared plus 16 is greater than 0. Now, we've got a negative in front of the x squared. So what difference will that make? Well, it'll make an unhappy parabola. The problem is that's going to be very difficult to factorize. So we would rather factorize if we have a positive in front of the x squared. So what can we do to get a positive in front of the x squared? Well, we can divide everything by a minus. Now remember, dividing by a minus will change all the signs, including the inequality sign. So if I divide by a minus, I will end up with x squared minus 16 is smaller than 0. And now we're back to a happy face or positive parabola. So we can use exactly the same method as we did in example 3. What we are concerned with is the two x-intercepts. So we will need to factorize the expression, and we end up with x minus 4, x plus 4 is smaller than 0. So what are those critical values? What are the answers to those two brackets? Well, 4 and minus 4. And if we want to know what area is smaller than 0, we want to know what area is below the x-axis. And it's the area highlighted in pink. So the solution to this inequality is x will be all real numbers that lie between minus 4 and 4. I don't have an equal sign on the inequality, so I use round brackets and not square brackets. In example 5, we've got x squared minus 5x plus 6 is greater than or equal to 0. Now this one is slightly different because we've got this middle term. Now we don't know how to sketch that graph, but we're hoping because of the square it's actually going to behave in exactly the same way. So I still have a positive or happy face parabola, and you will learn how to sketch these parabolas in more detail later in the year. But for now, we are hoping that we still have a positive happy face parabola. And the points that we were concerned with were the points where it crossed the x-axis. Now that is the point where the equation is equal to 0. So to figure out solutions to that, I would first need to factorize the expression. Now this is a trinomial, and you have been practicing factorizing trinomials for a little while now. This will be x minus 2 and x minus 3. And the solutions to that equation or inequality will be 2 and 3. Now we are concerned with the area that is greater than 0. So if we look at our summary, greater than 0 is the area above the x-axis. And again, I've got two places. I've got this first section, and that's the area from minus infinity all the way through to 2. We use a round bracket because there's no equal sign on the inequality. And we've got a second area that starts at 3 and ends at infinity. Let's do one final example. X squared minus 4x minus 5 is smaller than or equal to 0. We know it's going to produce a happy face parabola. We do have a middle term, but at the moment that's not going to bother us. We're just going to factorize our trinomial. And if we factorize the trinomial, we end up with x minus 5, x plus 1, smaller than or equal to 0. The x-intercepts on that little parabola will be at 5 and minus 1. Now we are concerned with the area smaller than or equal to 0. So we're concerned with the area below the x-axis. But because it's smaller than or equal to, we need to use square brackets. So it's the area from minus 1 until 5. So just to summarize the brackets, if you have a smaller than and equal to or greater than and equal to sign, you should use square brackets. And if you have a smaller than or greater than sign, you should use round brackets. And remember, infinity always uses round brackets. And now it's time to try some on your own.